Hi everyone and welcome back. So today we're going to look at 4.5. This is called the Fundamental Counting Principle, and there's a really short section that talks about it on page 483. So most of the notes I'm going to get is out of that other book that we use from time to time. All right, go ahead and put your name up at the top, put your class hour and today's date. And let's take a look. So the first thing I want you to do is go ahead and pause it and do the whole bell ringer first, and then come back to me as soon as you're ready, and then we're going to go through the whole thing. All right, let's take a look. It says, Tyler wants to take a class at the community center. The table shows the class options he is considering. All of the classes are offered only on Monday and Tuesday. Number one, according to the table, how many classes is he considering? So it looks like he wants to take a drawing class, a martial arts class, and a dance class. So that means there would be 3 options. Number two, how many days are the classes offered? Well, it's either on Monday or Tuesday, so that would be 2. Okay, then complete the tree diagram to find the number of different classes and end day outcomes. All right, so he could do drawing on Monday, he could do drawing on Tuesday, he could do martial arts on Monday or on Tuesday. So that means we will end up with martial arts on Tuesday. All right, and then the last one he wanted to do was dance. And he could do this on Monday or Tuesday. So that would mean dance Monday or dance Tuesday. All right, so then we're going to answer our question down there at the bottom. All right, so there we go. So there's all of our different little outcomes. All right, so how many outcomes were there? In this case, there would be 6. All right, 6 outcomes. Okay, we'll just fill it in. I thought there was a question at the bottom, but apparently not. So we'll just say there's 6 outcomes. Okay, so we're just counting them up. So we've kind of already done this before. All right. Okay, let's look at the objectives for today. So what are we going to learn? Well, what you're going to learn is to use multiplication to count outcomes. Use multiplication to count outcomes, and we're going to find probabilities. Okay? And part of that multiplication does go into finding it with probabilities. So we'll use multiplication to find probabilities, but just writing find probabilities will be fine. All right, so this goes super fast. You're probably going to want a calculator. If you don't have one, go ahead and pause and grab it because it does go super fast. We've actually done this before, as you probably noticed, with the little charts. Okay, the last time we did little trees, we just did them downward. So you can go down or across. So we're going to be moving along fairly quickly on this one. All right, this is a pretty short lesson overall, so let's go ahead and take a look. Okay, it says find the total number of outcomes when a coin is tossed and a number cube is rolled. Okay, so let's think about this. How many outcomes would there be if I flip a coin? Well, I can either get heads or I can get tails. So that means I would have 2 outcomes. Okay, now we're doing multiple events, so we need to multiply in the middle. And then it says a number cube is rolled. Well, if I roll a number cube, how many numbers are on a cube? There's 6. 1, 2, 3, 4, 5, 6. So there's 6. So we have 2 times 6, which is 12. And that's it. All right, letter A. Find the total number of outcomes when choosing from bike helmets that come in 3 colors and 2 styles. All right, so let's take a look at this one. So we have 3 colors. And we have 2 styles. So again, we're going to multiply, so 3 times 2, so there's 6 altogether. Okay, let's go to number 2. It says find the total number of outcomes from rolling a number cube with sides labeled 1 through 6 and choosing a letter from the word numbers. Then find the probability of rolling a 6 and choosing an M. All right, so first let's find the number of outcomes. So we have 6 numbers on our die, and we have to pick from the word numbers. So how many letters are in the word numbers? Well, we have N, U, M, B, E, R, S. So there are 7 of those. So we have 6 the first time to pick from, and then we have 7 of the next one. So that's going to have 42 different outcomes. All right, now they want us to find the probability of rolling a 6 and choosing the letter M. All right, so for this one, what we're going to do then is we're going to have a 1 in 6 chance to get a 6. And then M only occurs in the numbers, or in the word numbers, in the word numbers 1 time. So there's 1 out of 7. Remember, probability is yes over total. So how many ways can it happen over the total ways that it can happen? All right. So then for that one, we would multiply. So 1 times 1 is 1, and 6 times 7 makes 42. So the probability is 1 in 42. All right, and then let's go to example 3. It says find the number of different genes available at the gene shop. Then find the probability of randomly selecting a size 32 by 34 slim fit. Is it likely or unlikely that the genes would be chosen? All right, so let's take a look at this one. It says we gotta first figure out the outcomes, right? Yeah, so how many different genes are available? Okay, so we gotta find the outcomes. So it looks like we have 1, 2, 3, 4. We have 5 waist sizes. We have 3 different lengths. And then we have 3 different styles. We have slim, boot cut, and loose. So that would be 3 again. So we have 5 times 3. That's going to give us 15. I'm getting ahead of myself, sorry. 15. And then 15 times 3, which is 45. Okay, so we have 45 altogether. Okay, then it says to find the probability of randomly selecting a size 32, 34 slim fit. All right, so if I want to get it a 32 waist, well, there's only one way I can get it out of 5 times. So that would be 1/5 times, and then I need a 34 length. Well, there's 1 in 3 ways, so that would be 1 over 3. Okay, and then we need the slim fit, which is 1 in 3 again. And by now you probably figured out it's always the same. It's just 1 over 45. Okay? All right, so that's pretty much it for that one. Let's take a look, and let me see if there's another one on the next page. Okay, let's take a look at this one. Couldn't remember if there was more on another page or not. Okay, so 2 number cubes are rolled. What is the probability that the sum of the numbers on the cubes is 12? How likely is that the sum would actually occur? Oh, I forgot to do the likely or unlikely. Sorry, let me back up to the last one. Oops. Okay, let me back up. Sorry, you probably wrote it down. So is it likely or unlikely that you would actually pull this pair of genes out of the stack? Obviously, when you have 1 in 45 chance at it, it's very unlikely. So that would be unlikely. There we go. Sorry. Totally skipped over that part. All right, let's move on. All right, so we need to figure out first how many sums we have. So we're going to roll 2 number cubes. All right, so there's 6 numbers and 6 numbers. So we're going to have 6 times 6, which would be 36. So there's 36 different outcomes. And then it says, what's the probability that the sum of the numbers on the cubes is 12? All right, so how many ways can we differently get a 12? All right, so let's kind of think this out for a minute. So I can get, let's see, a 1 and a 6. Nope, that won't work. Let's see, just a 6 and a 6. So we can get a 6 and a 6 to make 12. We can get, oh, that's it. Yeah, because when you're playing a game, you can only get a 12 by getting double sixes. Yeah, okay, so that's it. So there's only one way that can happen. So we have a 1 in 6 chance of rolling a 6, and then a 1 in 6 chance of rolling 6 again, so that's going to be 1 over 36. All right, and then how likely is that going to happen? Very unlikely. Okay, well, we just say unlikely, but not impossible, but it does make it difficult. All right, so we have 1 in 36, and it's unlikely. Okay, and then example 4. It says a box of toy cars contains blue, orange, yellow, red, and black cars. A separate box contains a male and a female action figure. What's the probability of randomly choosing an orange car and a female action figure? Is it likely or unlikely that this combination is chosen? Okay, so let's take a look here. So first we got to figure out our outcomes. We have 1, 2, 3, 4, 5. We have 5 different colors. And then obviously there's only 2 genders. So we have 2 genders, so that's 10. So we have 10 different outcomes. Okay? Now we got to figure out the probability of each one. So first we have to get an orange. Well, there's only one orange in 5, so 1 in 5. And then to be female or male, they only have a 1 in 2 chance, which of course then makes 1 over 10. Okay? And then is that likely or unlikely? Obviously 1/10 of the try makes it unlikely. And there we go. All right, so this one's just kind of different. Okay, it's not, the math isn't too bad. We know all the math. It's just kind of piecing things from previous lessons all together into one big piece. All right, that's it for this lesson. Thanks for watching. Give me a thumbs up and subscribe if you haven't already, and I'll see you next time.